Hi, my name is John Goodland and I work within the Technical Enablement team here at Progress. Today I'm going to be walking you through an introduction to Flowmon, the network monitoring and reporting tool. Before we start, let's talk a little bit around IT security. The hacks, attacks and ransomware demands are happening at an ever-increasing pace, crippling organizations and costing millions of dollars in ransom payments, lost productivity and diminished consumer confidence. Why, with all the tools available in the market, are those issues still happening? How can you help your clients avoid this type of unwanted attention with Flowmon, solving today's application and network challenges? Flowmon introduces the most compelling and unmatched value proposition in the industry that will help you differentiate in the market to your customers. We are the first and only application experience platform that enables you to know that your line of business applications and the networks that they run on are available and secure at all times. Extract all packet flow and application telemetry for proper investigation. Monitor continuously in real time all network traffic and application behavior for anomalies. And last but not least, protect the enterprise from malicious acts by stopping threats before they occur. The Progress solution portfolio delivers the always-on application experience and intelligent threat detection that your users demand. The Progress Flowmon network detection and response solutions combine machine learning heuristics, advanced analytics to improve network performance alert on network anomalies and provides early detection of advanced persistent threats. The Progress Flowmon network performance monitoring and diagnostic solutions collect and analyze rich telemetry from various sources, saving hours of tedious network troubleshooting and accelerating time to resolution. The Kemp LoadMaster load balancing solutions, an extensive library of application deployment templates, provide high performance and secure delivery of application workloads from a wide range of vendors in multiple sectors. The Progress difference is clear. With the most capable solutions for load balancing, network performance monitoring, and network detection and response to ensure applications are always on and network issues are resolved before they become a problem. Today, there are 4 key areas I'd like to show you that should give you a foundational understanding on how Flowmon enables our customers to have the best application experience. First, you cannot manage and protect what you cannot see. I want to start by discussing how you can gain visibility into your network to eliminate blind spots. Second, I want to talk to you about how Flowmon can proactively reveal undetectable threats. This can reduce the time to detect current and future cyber attacks, protect your business. Next on our agenda today is application experience monitoring. So what is application experience? In this section, we'll explore this further. And finally, detect ransomware, expose insider threats and respond to them quickly while keeping your network transparent and problem-free. With that in mind, let's get started. Gaining visibility into your network, enabling you fast response to minimize impact on your business. Secure the gap between endpoint and parameter security and optimize the source of truth to build up a better detection and response strategy. First, I want to start by showing you how you gain immediate access to the important information via a single source of visibility. Everything you see today comes out of the box. I also want to explain how we, using Flowmon Probe as the flow data exporter, is the right method for truly rich insights. This right method is what sets us apart from just another flow detection and traffic visualization tool. And lastly, we'll walk through the intelligent decision tree, analysis based on decades of combined network experience provided by our in-house experts.
And that one is really like, let's imagine I'm a single administrator in the network, and every day, or I have this one somewhere in the background just to see if everything is good. So I can, by quick look, I can see, okay, I have some security events. I can see what kind of events are there. what are the source IPs, and just looking into this, if I set it up properly, I might know whether I have some problems I need to deal with or not. Of course, since this is a demo system, there is lots of events. In the live network where you don't have a huge network, I would say normally you should get this level of events into like ones or tens of per day, because the more you have, the less you can really focus on. So of course it's about proper tuning and letting the system work with it. Then there are different views, like to get link utilizations, host names, usernames, or anything like that. In fact, like all of this is fully configurable, because we know that every user has different needs to see what is important for him. So every user can have his own dashboard and see information which are relevant to them, like to see, I don't know, as a server administrator, I might want to see which TLS versions are being used, if there is any expired certificate, for instance, used somewhere in the network, or potentially if I have Camp Loadmaster somewhere, I can get like that kind of view to see the traffic which is passing through, whether there are any errors, what are the response codes, and what is the retransmission index, because for each TCP connection we are able to measure on the load master itself as well the performance data, so round trip time, server response time, retransmissions, auto forwarded packets, which will always indicate different problems on the network or with the servers in case of server response time, which might get higher. You can visualize it on the maps, so you can get that kind of map view, seeing how the links are utilized between different points. And from this point on, you can switch to analysis. So here you get understanding. I see here I have some problem. There is high spike. I want to investigate that. So I will go to the analysis, and that's where I receive all the flow data. Since you mentioned that it's not really clear what is the difference between flows and packets, so let's quickly check that difference. So I will list flow data just to give you the default view. And basically what we see here, every line like this is a flow record. What we see is like where it started, how long it takes. So that's basically, we know where it started, when it ended, what is the protocol source IP address, port, destination IP address, destination port, TCP flags, types of service for QoS, number of packets, bytes, and flows. This is pretty much the most basic information which is going to be provided by most of the flow sources. So this single record is going to have around 100 bytes. But then once we are talking about packet capture, we are going to have like the whole of this information, so this 552 bytes, and we are going to have it for all of them. So as you can see, during this 5-minute period, which I selected, or actually it's longer, it's like 10 minutes or something, 20 even, there was 1.67 gigabytes transfers, which relates to 1.4 million packets. So I would have actually this 1.4 million packets if I want to do some analysis. You can imagine that's going to take quite some time, as well as quite some space, because it will take nearly 2 gigs to store the full packets, even though for most of the cases, and that's coming also from some Gartner research, you are just fine with the flow data, because you can see we have about 47,000 flows out of 1.4 million packets. So with this flow information, we can easily get, okay, information like who talked to who, so I can check IP to IP conversation, so realize whether this spike is actually related to something I would expect, or if it's something unrelated to the business. So I see this is some communication with Google from one of the internal users, and I would probably guess maybe this wasn't really relevant to us. So if we look into it in the flows, we will see the IPs, how much they transfers, and we can have a look into the details. So we can say, okay, for this IP address, I want to see more details, so I see what kind of communication there has been. Also, if there is a Flowmon probe, I can go into more level of details. So that's the advantage of using Flowmon probe over over standard sources, or actually not only Flowmon Pro, but also Camp Loadmaster can provide this information, because we have, for instance, information about HTTP. So we might be able to see, thanks to analysis of server name identifier or other like DNS, and we can get understanding what kind of application has been used. Not only that it was TCP on this port, but we can see also what page has been requested or information like that, as well as I mentioned, we can spot this network metrics, which are really helpful when you are dealing with the situation like, okay, the bandwidth isn't really that heavily used, but still users report there is a problem with the application itself, that it's responding slowly. So like we can have a look here in this link, for instance, and we see round trip time on the network is 96 milliseconds. So from this IP address to the server of Google, it took 96 milliseconds, which is, I would say, probably quite good. Server response time, however, it wasn't measured. So for some reason we don't see it, but we might see probably it was actually some continuation of communication. So we might see also server response time. So we can say how long it takes for the server to respond to that request, and then jitter and delay. These two are actually relevant more only for real-time application like meetings or voice over IP, and then we see out of order and retransmission packets. Again, if there is many of them, generally there is going to be some problem with the buffer on a switch or router, that it cannot perform well enough. So these kind of metrics we have actually, or we can see also in the chart. So if I enable them, I will be able to see also the server response time, boundary time, and jitter. So I can select only those which I'm interested in, and see also how it's changing in the time. Because for instance, if I will see some relation that there is high traffic, at the same time the server response time is increasing, I would know probably that my servers are not able to handle it. If the server response time is okay and the round trip time is increasing, potentially I might have some network equipment overload issue. And this kind of analysis, it's generally gets really easy once you get into it.
So, to recap on the business benefits of what we have just seen. First, we talked about Flowmon gaining immediate access to important information. Flowmon provides a single source of visibility across the entire customer environment. Performance degradations can be seen immediately, and using capacity and available can be all monitored in near real time. In addition, bottlenecks can be revealed, errors can be analyzed, and detection can be automated. For truly rich insights, you need to use the right methods. This is where we leverage the Flowmon probe as the flow data exporter. The probe provides L7 enriched network telemetry, which is the key to unlocking the solution's full potential. Just-in-time packet capture helps shorten time to recovery when security incidents occur. Probes are what makes Flowmon different from just yet another collection and traffic visualization tool. And last, the Flowmon provides an automatic decision tree analysis of network protocols, their dependencies, RFC specifications and errors from the PCAP file, giving you an immediate number of issues found as well as their severity. This uses decades of combined network experience provided by our in-house team. The next thing on our agenda is protecting your business with network detection and response. In the context of the SolarWinds campaign, today's enterprise IT security leaders are increasingly concerned about the threat from nation states. But financially motivated cybercrime is still a more fearsome threat. Backed by an underground economy said to be worth over 1.5 trillion annually, cyber criminals have the tools and the know-how to get what they want. Our detection capabilities. This is where I show you how Flowmon detects suspicious behaviors, how threat intelligence analyzes network traffic for signs of malicious activity, and lastly, how simple is it with our threat response to prioritize events.
I want to show you today is the anomaly detection system, because that one is going to allow you to process the flow data which are on the collector and spot any kind of strange behavior, whether it will be communication with blacklisted hosts. So that could be potentially infected station, like we have here in this example. This station, as you can see, is talking with no command and control center. So most likely it's infected by some malware or something like that. Then you can also search just related events for this IP address, because right now we spotted that this IP address is somehow doing some strange things like talking to command and control center. Most likely it's not really a good one. So what we can see on this quick overview is that here we have this blacklist events, but then we see also it has been scanning the network, so trying to identify what's around it, right? So like you can see that it was scanning on TCP. So to map the network, identify potential victims for additional attacks. We see the IP addresses which has tried. We see ports. Sorry for that. I will need to call back, but not now. And there is also, oh, sorry. So that's for the scan. Then we have here some strange ICMP anomalies. ICMP protocol generally used to verify that something is reachable, or to provide statistic messages. Okay, this port isn't reachable, the service isn't reachable, or for purposes like that. And we can see for some reason this station has been using a big payload. So actually, to understand what was in the payload, we would need the packet analysis, and that will help us to see what was in the packets. We actually have it connected with the traffic recorder, so that's our solution to trigger packet capture, so we can see what is in them. Curious whether we will be able to see anything. Okay, we are. So let's open this, and probably this will help you to see what is the difference between flows and packets, because this is now varchar where I have the payload, and you can see this is actually the information we will never be able to get from the flow data. But you can see there is some text in it. So obviously, if this is something like, rather than just this lorem ipsum text in this lab, it will help you to see what has been transferred from this IP address to the destination. So most likely, some files has been transferred using ICMP protocol. So obviously, this isn't really normal behavior. And that's pretty much that, to the difference between packets and flows. With the flows, we have pretty much the information you see on top here. So time, source, destination, protocol, but we don't have that payload. But once you have the payload, and we can actually capture it as well if needed, you can see what has been inside if it's not encrypted. Once it's encrypted, you have pretty much the same information like with the flow. We have just how much was transferred, what are the source and destination IPs, what was the protocol, but we wouldn't be able to see what is in that data. So like this tool is then really to give you that kind of automatic processing, which will help you to find this like bad actors on the network, as well as some misconfiguration. So you can see if there is, I don't know, like something unreachable for the users. So you will need, okay, these users are potentially using some wrong server. Of course, not everything what is anomaly is security or configuration problem. It could be normal behavior. So in that case, you can mark it as false positive or modify the configuration of the method to work properly and not to detect this anymore. Because the aim is really to show you only the proper anomalies, so really to see only those which are potential threats or which have some problems. So here is some crypto mining, for instance, detected from the user. And there is various different use cases. Of course, you will be able to find all of this information by yourself if you open it in a monitoring center and start searching for this kind of behavior, but you can imagine that's going to be time consuming. So this anomaly detection system we offer is really there to help process the data automatically, so you don't need to do it by yourself, and then just check the events and behave based on what you see. So here again, we see the same compromised host, which has been, attacking by RDP some of the machines in the network. And just to have a look into the details, so we have here also user identity. So this information isn't actually part of the network traffic, but we can extend that once we have the logs from LDAP or Active Directory, which will tell us that on this IP address at this time, this user has been logged on. So we can then patch this together to say this IP address belongs to this user. So whenever there will be event, it's actually most likely coming from this user, or at least from his computer. So this way, if you have some dynamic environment where the IPs change a lot, you might not be able to identify just by IP address, or it could take you quite some time to figure out who was on that IP address. If you put this together, you can see the user right away and ask him directly without going to some other solution. Again, we have possibilities of various visualization. So you see already the search. We can use also this MITRE attack techniques to show you different events. So lateral movement, command and control, communication, and things like that. As you can see, these techniques have different methods assigned to them, and you can see which kind of technique is actually being used by that method. Also, you can do aggregation by host and sources, do searches by methods, because there is about 40 or 38 methods, which actually some of them work with the signatures. So it's also using signatures like to detect information on the blacklist or with some special behavior patterns, as well as various machine learning techniques for general anomalies, also to learn what is the normal transfer rate for the users, how much peers they have in general, how many emails are transferred by the users, and information like that. And then we are looking for the anomaly. So whoever has too much, usually not too little, but for instance, for some method, we are also looking for those which does not have any communication now, because it might help you to spot some service which is currently down. And also some aggregated view just to spot how it looked like over time for this IP addresses. So you can see if it's happening every time in the or every day in the night time, most likely it's strange, because these user machines shouldn't be running during the night time. Of course, as you can see, we have here in the demo pattern, because we are replaying the data, but there's also some kind of view which you might use. Again, reporting and everything, as you've seen on the dashboard, is possible. So you get all of that with the single blinds.
So to recap on what we have just seen, the first thing we talked about was detection capabilities and how, using machine learning, heuristics, and advanced analytics, Flowmon detects suspicious behaviors and allows IT professionals to detect risk that bypass traditional approaches to deliver actionable insights. Next, we looked at threat intelligence, which analyzes network traffic for signs of malicious activity and informs you about every suspicious or anonymous occurrences to give you a timely warning about unknown and insider threat actors operating in your network. MISP integration to automatically detect a threat to the network using indicators of compromise. MISP allows creating a big knowledge database based on data from multiple independent analytic teams across multiple companies. And last, we got to see Flowmon threat response, which provides us with the event priorities scoped by perspective, reports by perspectives, predefined and user-defined, and available in email and PDF, log management and firewall, NIC integration for hosting blocking, grey listing, and quarantining. Application monitoring. What is application experience? It's hard to quantify and monitor application experience. Application experience, AX, is the user reaction to their interaction with digital applications. It's critical to always deliver a positive and optimal AX. So the next thing I want to show you is how to deliver application experience. I will show you this using application topology. It shows overall traffic distribution among individual real servers and congestion of virtual service capacity. And key performance indicators, visualization of time series data for all your KPIs. And lastly, analytics. The top clients generating most volume of traffic or experience the worst network or application experience. So let's look at application experience monitoring.
Is this application performance monitoring, because with it we are doing TCP reconstruction, so we need to see into the packets to be able to provide you this kind of analysis or this level of analysis to see the responses, any error codes, how long it took. So here what we measure is any request which is going through to the application. It has to be HTTP, HTTPS or SQL application, and then we can measure how long it would take for this page to load up, whether this is somehow slowed down on the network. We can say, I'll see here, this one took 2.5 seconds. So on the network it was 0.009, so network transport wasn't the case. Thanks to that, you can say, okay, it has something with the server because it's take way long time to perform this request on the server. Also, we see here the SQL queries which were run at that time, and we see none of them is really long. So again, this will indicate for us really the problem is with this application itself. It's not most likely with the server, or it could be with the server, but definitely if we have other requests at the same time, potentially we need to check this call, or it could be somehow related to the any information like cookies. So that's everything you can see here because it's all taken from the packets. Again, here we have different alerting and reporting. This alerting is again same across the whole product. So syslog, SNMP trap emails, all of that is available.
So the first thing we talked about was application topology, showing application components and actors on a logical topology and connects the topology with a network telemetry. Primary Flowmon use case is bandwidth utilization with respect to defined capacity calculated as average of 95%. In context of application experience, it shows overall traffic distribution among individual real servers and the congestion of virtual service capacity. Next, we looked at key performance indicators. Flowmon provides users with clear and easy to understand insight into network performance metrics. In the context of application experience, retransmission can disturb application experience while round trip and server response time is not affected. And lastly, analytics. We saw the top-end statistics with respect to defined criteria such as an amount of transfer data, average round trip time, etc., visualized as a table accompanied with pie charts. In terms of application experience, we can provide the top clients generating the most volume of traffic or experiencing the worst network or application experience. Okay, ransomware detection and response. The last thing I want to talk to you today about is ransomware. For ransomware, early detection is even more important than most attacks because the damage done by ransomware may be irreversible. If ransomware encrypts data not included in a secure backup, then it may be irrecoverable even if the victim pays the ransom. For this part of the presentation, I will actually use screenshots to explain the process. This is inspired by a real customer case, full scenario replicated in the lab environment where I took these screens from. The features detailed here all contribute towards detecting the early signs of ransomware and respond before the danger escalates. First, using automation for detecting threats immediately. Then noiseless insights which provide accurate insights. With zero-day threat detection to learn about threats early due to the behavior pattern recognition. And finally, short incident response times as they are detected in near real time. So, how does ransomware detection work whenever there is a bad actor in the environment or when he enters the environment? Let's follow this in our real-world customer case. So whenever there is a bad actor in the environment or when he enters the environment, he needs to do some kind of understanding of what is around him. So he runs some discovery to understand what other IP addresses, services are there so we can establish and present itself to spread. So here's the typical first step. Second thing the attacker does is access to potentially important servers that will hold some data. The attacker can take a list of known logins and passwords so he can run a password spreading attack against a Samba server. Hopefully he won't be successful, so he needs something more advanced. In our case, what we used and what was used in the customer case was the Blue Keep vulnerability on the remote desktop protocol. This is something that can recognize with proper signatures for inclusion detection. On the Windows server, what was installed was a keylogger, and the keylogger actually revealed some interesting information such as user credentials for Samba server by the data that is stored. So now that we have a valid login credentials to access the data on the Samba server, we can download them and we can think of a method how to get this data outside of the network. So in our case, what we did, we took the data and split it into small chunks. We then just took the data straight out the network, working like a charm. So this is now basically getting to the final step, which means the encryption of the data on the Samba server. So responding to the threat at this stage is obviously too late. Because the attacker is now ready to send you an email asking for a ransom for giving you the encryption key for the data or asking you for some ransom for not putting your sensitive data in the public internet because it was exfiltrated. So usually there's an attachment to this email with a couple of documents showing the attacker currently has this data available. Followed by a vertical TCP, since where the attacker is looking for a services he can then compromise. So again, we can see the event details and we have the classification to correspond tactics and techniques that are revealed in this case. So using the anomaly detection system, we can actually see all these activities one by one. So we started with a network discovery. This is our attacker IP address and we see two activities. First is the ARP scan that looks for devices that are available on the same network. So here we have the attacker, the same attacker, and we have an event saying the attack against Windows Remote Desktop. And when we go to the details, we're interested in to relate intrusion detection, as you can see. There was a detection trigger that says exploitation of the Blue Keep vulnerability. So after that, the attacker was able to perform the data hoarding, so he was able to download large amount of data from the Samba server. So here we have again the same attacker. We have an event saying attack against a Windows Remote Desktop, and when we go to the details, we're interested into the relate intrusion detection. And as you can see, there was a detection trigger that says exploitation of the Blue Keep vulnerability. So after the attack was able to perform data hoarding, he was able to download a large amount of data from the Samba server. And this was followed by the data exfiltration from the network, where several different methods were actually triggered. Your general data upload anomaly will notify you about data leaving your organization to avert some public IP addresses. What will be more interesting is this anomaly is the ICMP traffic, because as I've mentioned, the attacker split the data into small chunks and pinged it out the network. And obviously, anomaly detection systems don't like ICMP traffic with a payload. So when we go to details, you can see the evidence. These are the ICMP packets aggregated into the flows that have been actually detected and flagged as an anomaly. And you can see here, it's not really a massive amount of data. It's not a lot of the packet. It's not a lot of flow. So this is not volume attack anomaly. And we have the full bucket capture available. So in this case, I'm going to download the full packet trace, and I'm going to open the packet trace using Varchar so you can see the ICMP traffic. See the ping including the content, which starts here with the file name followed by the content that was sent out. So that was our real customer case, going to end with detection to the analysis. So let's recap. First, using automation, the solution detects threats immediately without having to place any kind of burden on the user. As we have seen, the anomaly detection system, we see all these activities one by one. Next, with noiseless insights, Flowmon provides accurate insight using sophisticated algorithms, machine learning, heuristics, and artificial intelligence. And, but even better than that, zero-day threat detection. Users learn about threats early due to the behavior pattern recognition, which can detect anomalies from their infancy, preventing the danger from escalating. And last, using short incident response times, incidents are detected in near real time, providing context, including information for remediation. So that is a basic overview of Flowmon. So just to recap one last time. First, we spoke about how you can gain visibility into your network, enabling fast response to minimize the impact on your business, securing the gap between endpoint and parameter security, and optimizing a single source of truth to build up better detection and a response strategy. Second, we talked about how to protect your business. Flowmon supports rapid investigation, internal visibility, intelligent response, and enhanced threat detection across on-prem, cloud, and hybrid environments. Detecting attacks at the network layer works so well because it's extremely difficult for threat actors to hide their activity. Next was application experience monitoring. AX is the user reaction to their interaction with digital applications. It's critical to always deliver a positive and optimal AX. And finally, detect ransomware. Expose insider threats and how we respond to them quickly, as you have seen using our real-world customer case, while keeping your network transparent and problem-free. Progress Flowmon enables application and network visibility across data center, private or hybrid cloud environment, providing you with a holistic overview of your entire estate, detailed insights for troubleshooting and maximizing operational stability. Flowmon brings the fastest time to value because the solution is very simple. It takes 30 minutes to deploy it to get actionable insights. The moment it's deployed, you start collecting the data. You know if there's any threats, you have the visibility, you're detecting with threats in real time. Therefore, you're alerted on any issue. It's basically 16 times faster to resolution, so the value is there very quickly. And to close out this slide, I'd like to draw your attention to one of our statements from the customer, Amstel Land Hospital. We called our network formerly a black box because it was unclear what kind of traffic it turned. With Flowmon, you can quickly pinpoint on latency. To discover an issue, it now only takes 15 minutes. The value is right there. So at the start of this presentation, we spoke a little bit around IT security. Gartner states that action and response are more important than blocking and prevention, which goes with saying that firewalls are very good and there's definitely a place in security for those. But you need to be able to monitor the network to figure out and quickly respond if there are any threats. That was a high-level overview of Flowmon to give you an insight into the solution. If you would like to learn more, perhaps dive a little bit deeper into one or more of the subjects we spoke about briefly here, I will be more than happy to arrange a follow-up meeting. Thank you for your time.